Welcome to my Algebra 2 and Pre-Calculus series. I combined Algebra 2 and Pre-Calculus because they cover most of the same curriculum together, and there are only a few exceptions. So let's get started. Instead of starting with an introduction, I'm going to start with a review of Pre-Algebra and Algebra 1. And this is only part 1 of the review. Lesson 2 would be part 2. So to start off, sets. A set is a collection of objects. So it can be something like this. A, B, C, D. That is an example of a set. The elements are the objects that are part of a set. So in this case, A, B, C, and D are the elements. This example I have is 1, 2, 3, and 4. The elements are 1, 2, 3, and 4. Belongs to is a certain symbol. It's written as this, shown here. Doesn't belong to is the belongs to sign with a slash through it. So for example, 1 belongs to S. 5 does not belong to S. An infinite set is an unending list of distinct elements. On the other hand, a finite list is a limited number of elements. S is a finite set because it only has 4 elements. Set builder notation uses a variable to describe a set. For example, the set of all natural numbers, it can be written as 1, 2, 3, 4, ... But instead, you can write it as X, such that X belongs to all the natural numbers. The universal set, it contains all the elements in discussion. And it's usually the real number set. An empty or null set contains no elements. And this is not the same thing as a set that contains only 0. A Venn diagram is a diagram that represents sets. And it usually looks something like this. That is the set, and that is the universal set. Subset is when every element of A is an element of B. So 1 is a subset, sorry, wrong symbol. It's a subset of 1, 2. And over here, the rules of subsets. Every set is its own subset, and the null set is a subset of every set. Equivalent sets is when A is a subset of B and B is a subset of A. Basically, they have the same exact elements. The complement of a set is all the elements in the universal set that aren't in A. And this is the set builder notation for it. The intersection is all the elements that belong to A and B. Disjoint sets have no elements in common, so their intersection is the empty set. And the union of sets is all the elements that belong to A or B. A few Venn diagrams for these. For complement of A, you just shade everything around A. For intersection, given these two sets, you shade the middle. For disjoint sets, you just show sets that don't intersect. And for union, you shade everything, basically. Real numbers. So first, the natural numbers, like I mentioned, are 1, 2, 3, 4, etc. The whole numbers include 0. The integers are all the whole numbers and their negatives. So -3, -2, so on as well. Rational numbers is everything that can be written as a fraction. And the number line is a line such that every number corresponds with exactly one point. So this is the number line. This can be 0, this can be 1, this can be 1/2, this can be √2, so on. Speaking of √2, an irrational number is anything that cannot be written as a fraction, and the real number is all the numbers that lie on the number line. Real numbers can also be defined as all the rational and irrational numbers. Irrational numbers is the complement of rational numbers. This is where U is the set of real numbers. Some properties of real numbers. Let A, B, and C be real numbers. This is extremely important because we're talking about properties of real numbers. The closure properties. A plus B and A minus B are real numbers. A times B and A divided by B are also real numbers. The commutative properties. A plus B is equal to B plus A. A times B is equal to B times A. Associative properties. A plus B plus C is equal to A plus B plus C. A times B times C is equal to A times B times C. The multiplication property of 0, A times 0 is equal to 0. Basically, anything times 0 is equal to 0. And the zero product property, if x1 times x2 times x ... times xn is equal to 0, then one of those is equal to 0. And an important variation is given only two numbers. If a, b is equal to 0, either a is equal to 0 or b is equal to 0. I'm not giving any examples because we should know this from pre-algebra. Some more properties. The identity properties. A plus 0 is always A, and A times 1 is always A. The inverse properties. A plus the negative of A plus its opposite is always 0. A times 1 over A is always equal to 1. Distributive properties. A times B plus C is equal to AB plus AC. This is a key property, and it'll be really useful in algebra. Similarly, if you subtract the addition with subtraction, you get the same thing. So now a bit more further into Algebra 1. An algebraic expression is a collection of numbers or variables connected by algebraic expressions, operations. So for example, it can be 2 plus x, or x squared plus 3y cubed minus 71zy. An exponential expression is repeated multiplication. So 2 cubed is equal to 2 times 2 times 2, which is equal to 8. And this is written as a to the power of n is equal to a times times a n times. The order of operations is useful when you're dealing with real numbers, not variables. First one, work separately below and above each fraction bar. So first take in consideration the numerator and denominator of each fraction. And then use the remaining rules between parentheses and brackets. So first one, simplify powers and roots, then multiply and divide, then add, subtract, and negate. All of these are left to right. So an example would be, given something like 2x plus, sorry, not 2x, 2 plus 5 cubed minus 7 times 3 divided by 3 plus 9 times 6 plus negative 3. First, you'll take the numerator, and the innermost parentheses is this, 5 cubed minus 7. And 5 cubed is 125 if you calculate it. So that'll be 2 plus 118 times 3. And this would just become 2 plus 354, so it'll become 356. On the other side, the denominator, the innermost parentheses -3, we can take that out. And we'll turn it instead into 3 plus 9 times 6 minus 3. And this becomes 3. So it'll become 3 plus 9 times 3. And this is just 30 if we calculate it. So now you get 356 divided by 30. And this simplifies into 178 divided by 15. And this simplifies even further. No, 178, no. You have to first find the factors. And once you find out this isn't divisible by 5 or 3, then this is the simplest form. So an inequality compares two expressions: less than, greater than, less than or equal to, greater than or equal to, or between. So 2 is less than 3, 3 is greater than 2, and so on. For between, you can do 1 is between 0 and 2. Absolute value. So absolute value of x is the distance from 0 to x on the number line. And absolute value of a is equal to a if a is greater than or equal to 0, and negative a if a is less than 0. So the absolute value of 4 would be 4, and the absolute value of -4 would also be 4. Note that the absolute value of a is always greater than or equal to 0. Absolute value of a negative a is always equal to absolute value of a. Other properties, absolute value of a times b, absolute value of a times absolute value of b is equal to absolute value of a times b. And absolute value of a plus b is less than or equal to the absolute value of a plus the absolute value of b. This is known as the triangle property. The distance between point B and point A on the number line is the difference, the absolute value of the difference between them. So now we're not just considering from 0, we're considering from A to B. And that's it for today's lesson. Thank you very much. Bye.